This is test ID. This is test ID 2, and the subject is communications, and we are discussing question number 12. It's given in the question that you have an antenna, a signal is coming from an antenna, RF signal, which is passed through a low noise amplifier and then sampled at twice the bandwidth or twice the message carrier, 2fc, and then fed to A to D converter. Here, sorry, this should be sampled at, if you assume a RF signal which is being modulated onto a carrier of omega c, for a direct conversion we should sample it at fc itself, or that is multiplication by fc itself. Let's assume there is a band pass filter, and what you have here is a low pass data which is passed through a to D converter and then fed into a DSP. Now the question is, the total input power, that is the input power that is fed to the antenna, can vary from minus 100 dBm, let's call it P max, and then P min is minus 10 dBm. These are the two given things in the problem, and it says the gain of the LNA is equal to A. Now these are the given conditions in the problem. Now we need to find what is the resolution or number of bits necessary for the ADC such that this works properly. That is, it should be able to resolve, this A to D converter should be able to detect the smallest signal, that is the minimum power signal, also properly. Now we know that let's compute the signal power at the input of the LNA. Now we know that these units are given to be in dBm, that is nothing but 10 log the power, which is nothing but 10 log the power, this minus 100 dBm. Let's call it PIM divided by 1 milliwatt. This is normalized to 1 milliwatt. And this PIM, by substituting in this result, let's call it PI max, is equal to 10 power minus 10 into, this is actually, I'm sorry to say, this is P min and this is P max. This because there's a negative sign, this is a maximum quantity. So 10 power minus 10 into 10 to the power minus 3. The power minus t, which is equal to 10 power minus 13 watts. Now there is a small assumption in this problem that the LNA input impedance is usually taken to be 50 ohms. Hence the power, when you find it out, the power of the signal, the actual voltage signal that is applied to this point is V square. If let's apply a sinusoidal signal at this point, then the power of the signal is given by V square by 2R. Let's call it V max square by 2R, which is equal to 10 raised to the power minus 13. Now you have R is 50 ohms, so you get V max equals 10 power minus 11 into root of 10 power minus 11. This would turn out to be a number close to 3.26 microvolts. This is the peak voltage that is applied, that is the maximum signal, this is the minimum signal that is applied here. I'm sorry again, this is V min, let's call it V min. Now what is the maximum power? Similarly, we just apply in this formula and compute the maximum power that is delivered to this antenna, and substituting in this we can compute Pi max is equal to 10 power minus 1 into 1 e minus 3. Hence you have V max square by 100 is equal to 10 power minus 4. Hence V max is equal to 10 power minus 2, which is 10 power minus 1, root of 10 power minus 2, which is 10 power minus 1. Hence this is equal to 10 power minus 1 is 0.1, that is 100 millivolts. Now this is passed through the gain of the amplifier, the gain of the low noise amplifier. So the signal seen at the ADC, let's call it X, that is signal seen at the ADC. X min, the minimum signal that is seen here is A into 3.26 microvolts. X max is equal to A into 100 millivolts. Now we know that for an ADC the step size of the ADC, that is the minimum delta of the ADC, that is step size of the ADC, is given by Vmax upon 2 power n. Now this is the step size of the ADC. Ideally it is Vmax minus Vin, but since it is Vmax is much larger, one can say that Vmax upon 2 power n, where n is the number of bits of the ADC, is the step size. This should be greater than or equal to, this should be less than or equal to 3.26 microvolts into A. Now Vmax is given to be 3 into A into 100 millivolts divided by 2 power n should be less than or equal to 3.26 microvolts into A. A and A gets cancelled. From this you can estimate the number of bits should be greater than or equal to, by doing some just simple arithmetic, we can get 15 bits. You get a number close to 14.8 or 9, you can round it up to 15 bits. Hence the correct choice is